Hello viewers, welcome to another very interesting video in which we will going to see the effects of current unbalance in three-phase motor. I have also discussed the effects of single phasing in three-phase motors in one of my previous videos. So because these topics are very important and critical for the motor life, so every engineer and technician needs to carefully understand the concept of these problems. So if you haven't subscribed our channel yet, please don't forget to subscribe it. So in any three-phase machine, whether it's a generator or an electric motor, these are the symmetrical device. It means that they are meant or designed to operate in balanced sinusoidal three-phase voltages. So what happens when the voltages are unbalanced? In that case, for example, in an electric motor, if the line voltages are not equal, the negative sequence currents are introduced into the motor. So we will see the effects of negative sequence currents in a motor. First of all, you can see here that whenever there is a balanced voltages, only the positive sequence current will flow and the magnitude of three-phase currents are almost equal and there will only be a slight unbalance. Whereas if the line voltages are unequal, then the negative sequence current will also flow and this negative sequence current will be in the opposite direction to the positive sequence current in the same machine. And because of this, the flux produced by the negative sequence currents will be opposite to the flux produced by the positive sequence current and will ultimately result in the overall reduction in the net torque of a machine. And since the net torque is reduced, the useful work done by the motor will also reduce. Now we will see when the unbalanced currents start to flow in an electric machine, what will be the effects? First of all, it will cause excessive power loss in a motor. That even though the sum of the phase currents are equal in both the unbalanced and balanced cases, but in case of unbalanced current, the I square R loss in one of the phases will be so high that the overall power loss in case of unbalanced will be more as compared to the balanced case. Therefore, it will ultimately lead in excessive power loss. And since there is an excessive I square R or copper losses in case of unbalanced currents, which will ultimately increase the motor temperature and due to which winding insulation will fail and results in reduced motor life. Another effect is an increase in the vibration in the motor since due to the negative sequence current, the net torque is reduced, therefore there will be a vibration introduced into the motor. And finally, since both currents are flowing at the same time in an electric motor, therefore the net productive current will be reduced and ultimately results in a reduced efficiency. So this is a graph of a derating factor versus voltage unbalance. So this graph will show you that at what percentage the motor will get how much derate. For example, at 3% voltage unbalance, the motor will be derated at zero point 0.9. It means that if the motor is rated for 10 kilowatt, but if the voltage unbalance is 3%, then the total useful output we can take from the motor is 9 kilowatt. It means that if you operate the motor at 10 kilowatt even at 3% voltage unbalance, this will result in excessive heat in the motor and will ultimately lead to the motor failure. Some of the important facts that will occur in the event of unbalanced current. First is the ratio of voltage unbalance to the current unbalance is 1:8. It means that if the voltage unbalance is 1%, the current unbalance will be 8%. Another fact is the percentage increase in the motor temperature, which is equal to 2 times the square of voltage unbalance. It means that if the voltage unbalance is 3%, there will be an 18% increase in the motor temperature. And here you can see how dangerous is the voltage unbalance for the motor life. And in sequel to this fact, a 10% increase in the temperature will result in 50% reduction in the motor's life. And some of the warnings and recommendation at the end of this video are that don't run the motor if the voltage unbalance is greater than 5%, and the current unbalance should not exceed 10% on the motor, but it will be tolerable if the high phase reading does not exceed the full load ampere. It means that if the maximum current flowing in one phase is still less than the full rated ampere of the motor, you can operate that motor. But again, the voltage unbalance should not exceed 5%. So I hope you clearly understand the effects of unbalanced current in a three-phase motor. For more interesting videos, stay tuned and don't forget to subscribe our channel. Thank you for watching.